All right, so gas exchange, the main actor here is your alveoli right there. These are little air sacs. Everything you breathe in, the air eventually goes here. And you have here the pulmonary vein. And remember, this is unusual because it's high oxygen. And most of the time we think of veins having low oxygen. But it comes in here through the pulmonary artery from, remember which chamber? It would be the right ventricle. Comes in there and travels along the alveoli, and as it does, the concentration of CO2 in here is high. The concentration of oxygen or of CO2 inside is low, so it's going to move in. And same thing with oxygen. It's high on the outside, low on the inside of the blood. So you have that oxygen moving in, CO2 moving out eventually. Check out the surface area. Yeah, surface area. Really big. Oh, we look at human biology. Comes up everywhere. So here we go. High concentration of CO2 to low concentration of CO2. So remember, diffusion always goes high concentration to low concentration. And high oxygen in that air you breathe in. Remember, this is coming from the outside. So basically, draw what you just saw. So you got the alveolus right there, and you got your pulmonary, we'll say right here. And this is the capillary. Remember, these are like one red blood cell thick. The thickness of one red blood cell just kind of squeaks through here. CO2 gets out of the blood and into the air where you exhale it, and then the oxygen that you inhale goes into your blood. So this goes back to heart. Back to heart. And specifically, what part of the heart? Give you some wait time. Give me some wait time. Left ventricle. Yeah, remember this right here was from the right ventricle. Sorry, that's wrong. The left atrium. And it comes from the right ventricle. So remember 311, you have that diagram you can look at. So you need to know about type 2 nematocysts. They're a little bit chunkier and bigger. And then type 1, which are thinner. This is just the regular tissue is the type 1. That's why they call it type 1, thankfully. It's regular. Just creating that very thin layer that can increase that surface area to aid that diffusion. And type 2 is right here. And you can see these alveoli. Like some type 2s there. Type 1, type 1, type 1, type 2, type 2. And as we'll see, they have different roles. So here we have a capillary with erythrocytes. That's a fancy word way of saying red blood cells. And they're extremely short, so there's a short diffusion distance. Remember, diffusion is a lot easier if you have a short distance. You don't want to have a giant cell and a little tiny oxygen molecule have to get all the way to the middle. It's going to take forever. If you have a little cell and your tiny oxygen molecule, it's going to be much faster. So, yeah, type 1, very thin, permeable, very, very easy to get through. And here we have the type 2 nematocytes. The fluid helps to moisten, and this moistening helps diffusion. So that helps diffusion. That's so terrible you can't even read it. Helps diffusion to be moist. If you look at a worm, An earthworm. What's it like? You go up and touch and hold an earthworm, you will notice that it is moist, and that allows it to allows gas to diffuse through its skin. And if you dry out that earthworm, it'll die because it won't have enough diffusion going on in the dry skin in order for it to happen. And it's very important too, this word called a surfactant. And this is it's like a detergent basically that helps it from sticking. So these have to stay inflated, and that's because you have to have that surface area there. If you don't have the surfactant, these can stick to each other, so it gets sticky in here and it doesn't stay open, and then you don't have that gas exchange. So you need that surfactant. That's the number one, I think, from what I remember, reason why premature babies have struggles is because number one reason premature babies struggle. Because we know a second by second basis you need to breathe, and their lungs just aren't developed. They're not making that surfactant, so it's extremely difficult to get them to breathe. But they've made a lot of strides for sure. Oh, so here's the diagram. We should know all these parts. The main passageway is called a windpipe, or your larynx, aka windpipe. And let's see, this is the bronchus. I'm going to focus on my handwriting here. So it goes larynx, goes to bronchus, and then goes to the bronchioles. And then goes, let's see, after the bronchioles, it goes to the very end, which is the alveolus. That's that air sac that we just talked about. Smack kind of in the middle of your lungs, you can maybe guess, is your heart. This big structure, this outline, is your lung. And these two boxes are basically the same. This is the diaphragm. And this, I had to say the muscle. So the diaphragm muscle. And these little circles, you need a way to protect these delicate, your heart and your lungs. So you have your ribs to do that. And in between your ribs are your intercostals. Probably never heard of those muscles, but you've definitely eaten them if you've eaten ribs, like beef or pork ribs. What you're eating are those intercostal muscles. Maybe we could eat ribs in class. Demonstrate that. Dang, that's a good idea. And then here is your voice box. Okay. So breathing in and out. Here you see the air coming in, so that's inspiration. And this is kind of funny. Expiring, breathing out, is called expiration. Inspiration, expiration. So when you breathe in, your thoracic cavity, which is your chest here, it's got to expand. And to help it expand, these external intercostals contract. That helps move the ribs up. And also your diaphragm flexes, so it moves down, so it contracts. So breathing in, your intercostals contract and your diaphragm contracts. Now when you breathe out, your diaphragm relaxes. Now that's the main muscle that's working here. So the diaphragm relaxes, moves back up. You see it makes it smaller in here. Then you have these, it should say internal. This is incorrect. Okay, your internal intercostal muscles contract. Let's say intercostal intercostals contract. So those internal need to contract. So the outer ones contract to breathe in, the inside ones contract to breathe out. Now, decrease slightly the size of your thoracic cavity. So you need all these. I talk about all these different muscles. Intercostals. Well, let's add some more. So core muscles, external intercostals to inspire. Remember, the diaphragm contracts. Okay, makes that thoracic cavity expand. And then you have the sternocleidomastoid and the pectoris minor. So I'm not sure what that one is. Yeah, that's the sternum. Oh, the sternum is this. I'll have to check that out. And then to expire, or to breathe out, we have our internal intercostals contracting, breathing in, bringing in the diaphragm, relaxing. You can also push in your abdominal muscles here to breathe out even further. So we have issues, lung cancer here, and smoking is 87% of all cases. It's pretty drastic with this. Air pollution adds 5. And one thing to say about smoking, it's, you have all this lung cancer, but it doesn't matter how long you smoke, all the studies indicate if you quit, whenever you quit, your chances of death go down pretty significantly. So it's never too late to improve your habits and whatever we're doing. So air pollution, especially diesel, is bad stuff. And if you're around wood fires, it's really not that good to breathe in campfire smoke. It seems natural. It's really not good for you. And radon gas is not something we see too much around LA because we don't have granite is the main thing. It's our bedrock. It's either sedimentary rock or sediment. But in some buildings you can get, that can be a major issue. Secondhand smoke, which is a lot less now that you have no non-smoking restaurants. When I was a kid, the restaurants had a non-smoking section, and the whole place was smoke. Same thing with airplanes, right? The beginning of the 80s, think about being an airplane, people smoking. Well, everybody's going to be smoking. And asbestos is really bad, like construction sites. They've done a good job at Jordan making sure the dust gets dealt with here so we don't breathe it in. So, difficulty with breathing. With lung cancer, coughing up blood. Your chest doesn't feel good, loss of appetite, weight loss, fatigue. Obviously, if you have trouble breathing, you're going to be tired, not getting enough oxygen. And you got the survival rate. So treatments, you got chemotherapy, you have radiation, blasting it with a radiation. And you have surgery to remove it, and surgery. And they're getting more into transplants now. Like it's more of a possibility now. So here you can see, this would be your lungs, normal tissue here. And this little part here would be, so let's say lungs, this would be your heart. And something like this, you see they're looking for something abnormal here, something white that shows the thickness of the tissue. So this would be a cancerous mass in the lungs. And emphysema is a disease that people develop from smoking or other sorts of industrial, or they're exposed to, say, coal smoke or asbestos or silica through their job. So tobacco smoke and marijuana, a lot of people think Marijuana smoke is okay, but it's not. It's smoke. It irritates, increases your chances for getting sick. Just air pollution in general. Manufacturing, if you put mining. Manufacturing also be, if you're working construction, you're more likely to get exposed to those things. Sometimes it's, inherited. So you can have a collapsed lung from this, and heart problems because your heart is just really stressed out. It's not getting enough oxygen. It needs to pump a lot more, and that creates issues. And then all the way leading up to holes in the lungs. So this would be our normal alveoli, non-emphysema. This is healthy. Over here would be emphysema. You can write the same thing here. So you'll notice there's hardly any air sacs here. Look at all these air sacs. Here you have a really high surface area. High surface area. Over here, you don't have all those air sacs, so we have low surface area, where you're going to have low diffusion. So this is where they might have to have an oxygen tank. Probably seen some people because they just can't cope with alveoli like this, just not a surface area. This would be your emphysema example, and this would be normal, kind of like what we just saw. All these air pouches, all that surface area, beautiful. Look at all that blood coming and interacting with the air here. Just not as much, right? All this empty space. Empty space here is not good. So this is pretty cool. This is a cool diagram. This shows you the external intercostals and your internal intercostals. Internal. And it's a great example of an antagonistic set of muscles. Right next to each other, this one contracts and ribs go out. The inside one contracts, the ribs come in. It's really cool. It's right next to each other, performing opposite functions. So again, antagonistic. All of our muscles are antagonistic. One makes the bone go the other way. The other makes the bone go the opposite way. Okay, so breathing in, internal intercostals contract. And you breathe in, the diaphragm goes down, moves down, and we have our internal intercostals contracting when you breathe out. In the air, exhale. So here I want you to read that on 312 and list those variables.